Hello, thank you so much for tuning into my YouTube channel. In this video, I want to compare the performance of a simple feed-forward neural network with a convolutional neural network when it comes to object detection. The problem of object detection here is going to be the same as the one explained in a sixth video that I uploaded to my channel. So we're gonna see which one works better in detecting a simple rectangle in an image. Let's get started. So we have already made a video on a simple object detection using a feed-forward neural network. That video could be watched on the sixth video that I uploaded into my channel. In this video, I'm gonna use a convolutional neural network to do the same problem of object detection and compare the results to the feed-forward neural network that we already used one time. So let's see what's gonna happen when we add a layer of convolution to the network, and we're gonna compare the results of applying convolutional neural network with the simple feed-forward neural network. So to remind ourselves of the object detection problem that we explained on the sixth video, we are gonna construct images through making a bunch of 8x8 NumPy arrays, setting the background to 0 and a random rectangle within the array to 1. And here are a few examples. White is 0 and black is 1. So this one is 0, white, and this one is 1, black. So we are again synthesizing a simple rectangle in a small image, and we're going to detect this rectangle. These rectangles in the image. The feed-forward neural network has one hidden layer, no convolution. It takes the flattened image, which is gonna be 64 values as input, and predicts the parameters of the bounding box, the coordinates x and y of the lower left corner, and the width and height of the rectangle. So on the left side is the feed-forward neural network. There's no convolution. The flattened image is going to be used as the input, not the image itself. So it's first flattened and then it goes through one hidden layer, and it would output xy of the lower left corner of the rectangle and width and height of the rectangle. On the other hand, the CNN here consists of two hidden layers. One convolutional layer and one dense layer. Therefore, the network gets in the image containing the rectangle shown before, right here, and after going through the convolutional layer, which is here, and dense layer, it outputs the parameter of the bounding box. Again, the same thing, coordinates of x and y of the lower left corner, the width and height h of the rectangle. So this is the big advantage for the convolutional neural network, and we don't know still, but I predict that convolutional neural network is going to act better. It's going to lead to a better result compared to the feed-forward neural network. So as you can see, the image is not flattened at first, and it goes through 4 filters in the first hidden layers, the convolutional layers, and then these 4 features, in other words, that have been obtained through filtering this image, they are going to be flattened and they are going to be fed into the second hidden layer, which is a bunch of neurons. So 2 layers, but this we only have 1 layer, and the output is going to be the same. Again, the same as the last video. We're gonna calculate the mean IOU over all the images in the testing set and compare the results to see which method has led to a better result. IOU, intersection over union, has been explained, as I said, extensively in the 6th video as well. So let's have a closer look at the coding in Python. We'll also get some run to see which method leads to a better result. Let's go to the coding part then. Okay, here's the coding part for feed-forward neural network. We already talked about it, and I'm not going to go through everything. Here are the images that are going to be synthesized, and the images are going to be normalized to have mean 0 and a standard deviation of 1, which would help the training in neural network. And these are the characteristics of the rectangle, including x and y and width and height of the rectangle. They're going to be also normalized to be between 0 and 1. And the important thing here, as a reminder, this is the network, very shallow feed-forward neural network with 800 neurons in just one layer. And here is the convolutional neural network. Everything is the same, the way images are synthesized, the normalization, the number of images, but the only thing that is not the same as feed-forward neural network is the convolutional neural network itself. The image is not going to be flattened just like here. The image is already flattened when it comes into the network, but here image is not flattened. An 8x8 image is going to go through the convolutional layer, 4 filters that's specified here with the ReLU activation function, and right after the convolutional layer, there's going to be the input is going to be flattened, and it's going to be fed into another dense layer with 200 neurons, and then 400 neurons right after that. It's going to be the output of the network. The 4 neurons stands for x and y and width and height of the rectangle in the image. So this is everything is the same, but only the convolutional neural network is being used. But for this one is the feed-forward. Let's get the run and see which one works better. Let's start with the feed-forward neural network. We start running it. It's going to make sure that it's going to use the GPU available, and the epochs are going to be shown the error because of the verbose 2 here. Let's go to the end and see what the error is for feed-forward neural network. So here is the error that we have got using it's actually IOU, mean IOU across all the testing samples, which is 0.84, and these are 2 examples, which is 0.75 and 0.93 IOU intersection over union. So let's get a run from CNN and see what would be the IOU using CNN for. So let's just remember this one. IOU is 0.84. I'm gonna write it down. 0.84 mean IOU using feed-forward neural network. Let's go to the CNN. Okay, let's go for CNN. I just resetted the Python so that everything will be ready for CNN running. Let's go to CNN. I already explained the network that we're gonna use for convolutional neural network, and let's just run, see what the results will be. It again checks on the GPU, and yes, awesome. It's gonna go through epochs. Let's go to the end of this video and see what the results will be. So as you can see, the results for intersection over union is 0.91 as opposed to 0.84, which we obtained using feed-forward neural network. And these 2 examples are also showing that the convolutional neural network has led to a better result. And this is just a simple example to see how convolutional neural network, how much better it is compared to a simple feed-forward neural network in a very simple object detection using neural network. So that's about it. Thank you so much for watching this video. I think it was obvious that the convolutional neural network would result in a better outcome compared to a simple feed-forward network when it comes to object detection, or for anything else for that matter. And in this video it was fun to see that the convolutional neural network really leads to a better result when it comes to object detection. And if you like the video, don't forget to subscribe and share it with your friends. I hope you enjoyed it, and have a nice day.